Alright, so the next part that we have to look at is problem solving. So now we're going to start looking at equations with radicals in them. So far we've just been simplifying radicals on their own. Okay, now we're going to look at solving for x when we have radicals in the equation. Okay, so we're going to utilize the power rule, which just states that if both sides of an equation are raised to the same power, so like if I square both sides or I cube both sides, all solutions of the original equation are among the solutions of the new equation. Okay? Now, those are emphasized for a reason, because sometimes we have multiple solutions, first of all, okay? Especially if it's a quadratic or something, we're going to have two solutions, things like that. Okay, but what it's telling me here is that when I square both sides, there's a possibility that I may get more answers than I would have for the original. Now, all of the answers to the original are going to be inside that set that I get. So, say I get x's 2 and 5. That means my original equation either had answers of 2 or 5 or no solution. Okay, it's not going to have any other solution. So, all of the solutions that were part of the original were in the set of the new solutions for the new equations. But I can get extra answers. Okay, if I square something, I might get an answer that I wouldn't have had before. So we call those extraneous solutions, which is just the solution that is found that makes the original equation false. So basically, I'll square both sides, I'll solve for x, I'll get x is 2, but when I plug it in and check, it doesn't work in the original equation. Okay, so maybe 2 is going to make a false statement. So that means that that's an extraneous solution, and you would just mark it as such. Now, that does mean that you absolutely have to check on all of these. Okay, if it says check, you have to check. You really need to check every single one of them. Okay, in your homework, it specifically says check for extraneous solutions. So make sure when you're doing your homework that you check for extraneous solutions, or you're going to lose half your points on all of those problems. Okay, so the steps. Okay, the very first step says that we need to isolate one radical on one side of the equation. Okay, just one radical. Sometimes I have 2 or more radicals in the equation, but we're going to pick one of them that we're going to work with, and we're going to isolate it on one side of the equation. So just the radical on that side, and all the stuff that's inside the radical would be with it. Okay, then we're going to raise each side of the equation to a power equal to the root of the radical. Okay, so if it's a square root, then I'm going to square it. If it's a cubed root, then I'm going to cube it. If I've got a fourth root, I'll raise it to the fourth power, and so on and so forth. Okay, so once I do that, if I still have a radical term, okay, then I'm going to repeat those steps. So I'll isolate that radical that's there, raise it to that power that matches the root, and so on and so forth. Once I get past that, then I solve the equation. So at this point, I should have no more radicals. Okay, I should just have some basic algebra, okay, that I need to solve for x. And step 4 says check all proposed solutions in the original equation. Now you have to go back to the original. Okay, you can't square both sides and use that. Okay, you have to go back into the original to see if it works. If it does not, then we would call it extraneous, and you would just write extraneous out to the side of it. Okay, so for instance, on example 1, okay, let me actually work these out for you instead of talking about them. So for example 1, I've got the square root of 2x minus 3 equal to 9. Okay, it is isolated. Okay, the only thing that I have on the left-hand side is this radical with all the stuff underneath. I don't have anything in front of the radical. I don't have anything extra added or subtracted to the radical. Nothing's multiplied or divided. So this is an isolated radical. That's what we mean. Okay, there is stuff underneath, and that's fine. We're going to get rid of the radical. Nothing inside this radical can move until the radical is gone. Okay, so to get rid of the radical, it says raise both sides to a power that matches the root. Well, this is a square root, which means we will square both sides. Okay, so here, when I square a square root, it just cancels each other out. Okay, because this is going to give me two groups of 2x minus 3, so that group would come out. So I just get 2x minus 3. Okay, that's what it does. Squaring a square root just is whatever's underneath it. That's all it is. Okay, 9 squared is 81. Well, now it's just basic 8th grade algebra. Add the 3 over to the right. 2x is equal to 84. Divide by 2. Divide by 2. X is equal to 42. Okay, we have to check that. It's not an option. You have to check it. You will have to check it on your test. It'll say check for extraneous solution, so without it you're going to lose points. So 2 times 42 minus 3 equal to 9. Okay, that would be the square root of 84 minus 3 is equal to 9. Square root of 81 equal to 9. Square root of 81 is 9. Now what I will tell you is this. Okay, when you are working these out for the check, you need to just work out the left-hand side and see if it matches the right-hand side. Because what happens is sometimes we just mentally make a mistake. So say I square 9 and I get 18 instead. I multiply it by 2. Well, if I square it here again, our mind automatically just assumes that our logic is correct, and sometimes that we'll just write 18 again. Okay, so if I said 9 squared was 18 the first time, I'm not going to rethink about it. I'm just going to do 9 squared is 18 over here. Well, it's incorrect, and my answer is going to be incorrect, but it's going to look correct. Okay, so whenever you do this, don't square stuff over to the other side and add or subtract it, because if you do that wrong, but you make the same mistake twice, then it's going to look like your answer is right when it's really not. So this does check, though. 9 does equal 9, so x equals 42 is a solution. Okay, example 2. Here, I don't have an isolated radical. We have to isolate first. See, this radical ends right here above the 1. Okay, so this plus 5 is outside of the radical. This stops here. Okay, the plus 5 is outside. So I have to isolate the radical first. So I need this to be all alone. So I have to get rid of this plus 5. Okay, to get rid of a plus 5, you got to subtract 5. Okay, so now I've got the cubed root of x plus 1. Okay, the cubed root of x plus 1 is equal to a negative 2. Okay, cubed root of x plus 1 is equal to a negative 2. So now, isolated radical on the left. Okay, here we go. So if it's a cubed root, instead of squaring, this time I'll raise it to the third power. Okay, I have to raise it to the third power. You raise it to the root or the power that matches the root. This is the third root, so I'm going to raise it to the third power. Both sides. What I do to one side, I have to do to the other. So here they cancel. The cube root of something cubed is just itself. Okay, and negative 2 cubed. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Okay, solve for x. Subtract 1 over. X is equal to negative 9. We have to check this thing, so here we go. Okay, plug it in. Cubed root of negative 9 plus 1 plus 5 is equal to 3. Okay, again, the radical ends right here behind the 1, so that plus 5 is outside, and you'll do that in a second. So we get cubed root, negative 9 plus 1 is negative 8 plus 5 equals 3. Okay, the cubed root of negative 8 is negative 2 plus 5 equals 3. 3 is equal to 3, that does check. So x is equal to negative 9 is my solution. Okay, x is equal to negative 9. It's kind of hard to see on that screen. Okay, x is equal to negative 9 is my solution. So, isolate the radical, raise it to the root, raise it to the exponent that matches the roots. So I put it to the third power because it was a third root, and then solve for x. Okay, even if there's 1 on either side, it doesn't make any difference. I still want to isolate 1, so I've got 1 alone on the left. It doesn't really matter which one you work with. Okay, it is a third root, so I will raise it to the third power. Both sides. Like always, everything you do, it's got to be symmetric there. Whenever you do to the left, you got to do the right-hand side of the equation. Okay, so the cubed root of x plus 5 cubed is just itself. And the cubed root of 2x minus 1 to the third power is just itself. So just finish solving for x. You get your variables on one side, so I'm going to subtract the x over. Okay, so I get 5 is equal to x minus 1. Now I want to get the 1 to the other side, so I'll plus 1. 6 is equal to x. So x is equal to 6. Check that. Okay, you got to check. Always got to check. So plug it in. I get the cubed root of 6 plus 5 is equal to the cubed root of 2 times 6 minus 1. Sorry, I'm working off the screen again. Okay, so cubed root of 6 plus 5, I'm just plugging back into my original equation. Okay, 6 plus 5 is 11. 2 times 6 is 12, minus 1 is 11. Okay, you don't have to go any further than that. You don't have to keep going. The cubed root of 11 has to be equal to the cubed root of 11. Whatever decimal that may be, it definitely has to be the same. Okay, so x is equal to 6 is my solution. Now 4 is a little bit different. Okay, if you're taking notes or not just watching, then you might want to make sure you kind of write small. It's going to take a little bit. Okay, because I've got two radicals here. Here I had a radical on either side, yes, but I didn't have anything else. I didn't have any numbers, and the roots were the same, so when I cubed it, all that stuff went away. That's not going to work out quite as well here. Okay, but I still follow the same thing. It says to isolate one of the radicals. Well, I've got two radicals over here, so I need to move one over. So I'm going to get rid of the smaller one. Okay, minus the square root of 2x. Okay, I'm going to get rid of the smaller one just because. It doesn't really matter. Okay, just because it's smaller, so that's what I moved. Alright, so now I move the square root of 2x over. So I've got an isolated radical. So over here on the left, I've got the square root of 2x plus 5. And on the right-hand side, I've got 3 minus the square root of 2x. Okay, same process. So raise it to a root, or raise it to a power that matches the root. This is a square root, so I will raise it to the second power. Okay, and I have to raise everything. So notice my use of parentheses in all of these. Okay, so squaring the entire side. Well, this is a binomial. Okay, and it's minus, so you cannot just square the outside terms. That only works if they're opposites. They have to have a plus and a minus. These are going to be exactly the same. I have to write this out and FOIL. Okay, it has to happen. So on the left-hand side, it makes it nice, though. The radical is going to cancel out with the exponent. Square root of something squared is just itself. Okay, but over here, we're going to have to FOIL this thing out. Okay, so here we go. We got to FOIL it. Left-hand side stays the same for now. Okay, 3 times 3 is 9. That's the first. 3 times negative square root of 2x is negative 3 square root of 2x. Negative square root of 2x times 3 is negative 3 square root of 2x. Negative square root of 2x times negative square root of 2x. The two negatives makes a positive. And 2 times 2 is 4. And x times x is x squared. Okay, first makes 9. Outside. Okay, 3 times negative root 2x. That's this. Inside. Negative root 2x times 3. That's this. And last. Negative square root of 2x times negative square root of 2x makes positive square root of 4x squared. Alright, so now let's simplify everything. Those are like radicals, so I can put them together. So 2x plus 5 is equal to 9. Negative 3 and negative 3 makes negative 6 square root of 2x's. Okay, if you don't remember how to add radicals, you need to go back to the last unit and learn. Okay, square root of 4x squared, square root of 4 is 2, square root of x squared is x. Okay, looking at those groups, square root of 4 is 2, square root of x squared is x. So now, I still can't solve though, because I still have a radical. Okay, so if you look back at your steps, it says, on step 3, if the equation still contains a radical, repeat step 1 and 2. So now we've got to go back to step 1 and isolate the radical again. So I need to get this little guy right here by itself. Okay, so I'm going to start off, I'm going to move the number over to the left. Okay, because I want to leave this one over here on the right all by itself. So there goes the 9 gone. Okay, I've also got a plus 2x over here. So I'm going to minus 2x to both sides. Okay, so that it's gone over here. Okay, great thing is that it happens to go away here too. 2x minus 2x is 0. 5 minus 9 is negative 4. Okay, I still have a negative 6 in front. Remember I said isolating radicals means that you can't have anything out in front or out behind it. You have just the radical. That's what it means to isolate. So this means negative 6 times the square root of 2x. So to get rid of multiplication, I would divide by negative 6. Okay, because negative 6 divided by negative 6, those cancel, or they divide out to be 1, so I get 1 square root of 2x. Okay, negative 4 divided by negative 6 is positive 2/3. That's just reducing 4 over 6. Okay, now I've got to get rid of the radical. So this is a root 2, so I'm going to square both sides. Okay, 2/3 squared, I'm going to have to come right up here. 2/3 squared gives me 4 over 9. 2 squared is 4, 3 squared is 9. Square root of something squared is just itself. Okay, and then we just divide by 2. Okay, then you just divide by 2. Okay, 4/9 divided by 2. Okay, you can use your calculator if you want to on your fractions. That's fine. Okay, not that big of a deal. Okay, if you don't, it's going to be times 1/2. Remember, dividing by 2 is the same as multiplying by 1/2. So I would get 4/18 is equal to x, which reduces to 2/9. Okay, so x is equal to 2/9 is my answer. I do need to check it. Okay, you can use your calculator to check it. That's fine with me. Okay, when I go to check, let me draw a little line here so I don't confuse myself. Okay, when I go to check, as long as you show the plug-in part, 2 times 2/9 plus 5 plus square root of 2 times 2/9 equals 3. Okay, as long as you show the plug-in part and then show the 3 equals 3 part, I'm okay with that. Okay, just show your little check mark. I'm actually going to work it out just because fractions don't scare me. So 2 times 2/9 is 4/9. If I want to add 5, I need a common denominator, so top and bottom by 9 gives me 45/9. Okay, if you divide 45 by 9, you go back to 5. Plus the square root of 2 times 2/9 is 4/9. Okay, well this would give me the square root of 49 over 9. I'm going to go ahead and reduce this. Square root of 4 is 2, and the square root of 9 is 3. Square root of 49 is 7. Square root of 9 is 3. 7/3 plus 2/3 makes 9/3. And 9/3 equals 3. So 3 does equal 3. It does check. Again, though, you can do that all in your calculator. You just got to be careful when you enter it in. So x equals 2/9 is our solution. All right, we got a couple more here on the back, or on the next page, rather. Okay, so example 5, same sort of thing. So here we go. I'm going to subtract my 5 over because I got to isolate my square root. So 4x minus 3, okay, is equal to a -3. Now, when I get there, okay, if you remember, a square root can't equal a negative, okay, because if I take the square root of a number, remember I couldn't have a negative underneath, so my answer is not going to be negative. Once I've isolated radical, and this only works if I've isolated the radical, if I isolate the radical and I have a square root, really an even root, okay, it cannot equal a negative number. Okay, even roots cannot equal a negative number. Okay, because if I can't take the square root of a negative, then I can't get a negative for an answer. So that's only if I've isolated. If I still have other stuff, then it's not the same thing. You have to isolate, but once it's isolated, an even-rooted radical cannot equal a negative number. Okay? But let's just, so that means this would be a no solution. That would be my answer. Okay? But let's just say for a second that you forgot this rule or you just missed it. Because sometimes when we're taking our tests, we're so involved with, okay, I got to square both sides and I got to do all this, and we just forget about the little rules like the even-rooted radicals cannot equal negative. So let's just say that I went ahead and I did the square for both sides. Okay, I would get 4x minus 3 is equal to positive 9. Okay, this is done. You don't have to do the rest of this. This is a for instance, because a lot of us do forget we forget these little rules that help us out, and we keep working things out anyways. So let's say I squared it, and I just kept solving. I would get 4x is equal to 12, and I would divide by 4. I would get x is equal to 3. And then I would try to check it, because that's what you have to do. I would check to see if it's extraneous, and I would plug it in. So the square root of 4 times 3 minus 3 plus 5 equals 2. So that's the square root of 12 minus 3 plus 5 equal 2. That would be the square root of 9 plus 5 equal 2. 3 plus 5 equal 2. Well, what do you know? Lo and behold, 8 does not equal 2. Okay? Which means that the solution that I got was extraneous. Okay? So that means it doesn't work in the original. So either one of these answers would be acceptable. If you worked it out and you got x is 3, but you checked it and you found out it was extraneous, this works because x is equal to 3 is extraneous, which means it doesn't work, and I don't have any other solutions, thus it is a no solution thing. Okay, when we do quadratics, sometimes one answer will be extraneous and one answer will work, in which case it won't be no solution, so that'll be a little different. But here, the only answer that I got wasn't really an answer, thus it is a no solution. Okay, so either one of those answers would work. I would be okay with that. No solution, or the solution that I got is extraneous. So either one works. Okay, there is a your turn. If you want to hit the pause button, you can do that, see if you can get the correct answer. I'm just going to keep on going. So add 4 to both sides, cubed root of x minus 2. We're going to go a little faster through this. Okay, we're going to go ahead and cube both sides. On the left-hand side, the cubed root and the cube cancel each other. 5 cubed is 125. Add the 2, and I get x is equal to 127, if my pencil will work. Add the 2, so x is equal to 127. If you stopped there, then you're missing a step because you have to check for extraneous solutions every single time. Cubed root of 127 minus 2 minus 4. Okay, so that would be the cubed root of 125 minus 4, which would be 5 minus 4, which would be 1 equal to 1. So it does check. X is equal to 127 is my answer. We did fantastic. Yay us. Alright, so now Pythagorean theorems. Okay, Pythagorean theorem, and I'm just going to put it up here if you want to hit the pause button because I've already written this 6 times today and I just don't want to write it again. If A and B are the lengths of the legs of a right triangle and C is the length of the hypotenuse, then A squared plus B squared equals C squared. Now the only thing that most of us are pretty good with Pythagorean theorem, most of us know Pythagorean theorem. Typically the only issues I ever see is that sometimes we don't identify the hypotenuse correctly. Okay, the hypotenuse is the one across from the right angle, okay, and the hypotenuse has to be the one on the right hand side here. The two legs, the square of the legs added together is equal to the square of the hypotenuse. It is not okay to put your hypotenuse as A or B. Now these two sides can flip back and forth. I can do B squared plus A squared or A squared plus B squared, that doesn't matter, but it has to be equal to the C squared. Okay, so that being said, let's take a look at that next one, which should be pretty simple. Okay, if you look at it, I've got 4 meters on one side, 10 meters on the other side, and I'm trying to find that third leg, which is B. Okay, well, across from that, so this is my C. Okay, so A squared plus B squared equals C squared is my Pythagorean theorem. So I'm just going to plug in 4 squared plus B squared is 10 squared. Okay, so we get 16 plus B squared is equal to 100. Subtract your 16. B squared is equal to 84. Okay, now if I want to get rid of a square root, I square it. So if I want to get rid of a square, I will take the square root of both sides. Now technically, anytime I do that, I should really get plus or minus the square root of 84. Okay, every time you take the square root of something, you're supposed to include a plus or minus. But I'm talking about the length of a triangle here. Okay, so I don't even care about the negative. The only thing I'm going to look at is the positive. Okay, but later on we will do a unit where that plus and minus is key and essential. Actually, I think it comes later in this unit. Alright, so B is equal to the square root of 84, okay, meters. This would be my exact value. So if they wanted the exact value, this would be it. Although I could technically reduce that down and get a simplified version of that radical. Okay, but this is exact, but if they didn't ask for exact, they wanted an approximate, that would be 9.17 meters. Just throw the square root of 84 in your calculator, and it'll give you approximately 9.17 meters. That, of course, is rounded. Always round. Okay, if you're gonna work with decimals, you have to round, and you have to round properly. Okay. All right. So example 8, last one here. 50-foot supporting wires to be attached to a 75-foot antenna because of surrounding buildings and sidewalks and roadways and whatnots. The wire must be anchored exactly 20 feet from the base of the antenna. How high, okay, so that's what I'm looking for, how high from the base of the antenna is the wire attached? Okay, so I've got some antennas sticking up, okay, And it says that I have a 50-foot supporting wire to be attached to a 75-foot antenna. So if my antenna is 75 feet, okay, the wire can't be attached to the top because the wire is only 50 feet long. That wouldn't be very supportive if it's just dangling next to the antenna. Okay, so that means it's attached somewhere down here. Okay, and then it's anchored to the ground. That's what supporting wires do. Okay, they kind of help hold these things up in place for when the wind blows and all that stuff. So here's my supporting wire. Okay, so if this is my wire, well, I know my wire is 50 feet. So that means this piece right here is going to be 50 feet. Okay, I also know that the wire must be anchored exactly 20 feet from the base of the antenna. Okay, so where it's anchored at, okay, it says from the base of the antenna. Well, I know it can't be this way, okay, because we do technically have two anchors here and here. Okay, but I can't be talking about this way because they wanted to know how high from the base of the antenna is the wire attached. So I'm looking for this. So that makes this my 20 feet. Okay, so from the base to where it's anchored down, that's my 20 feet. So now we got to figure out from the base to where it's attached to the antenna, how high up is that? So this is Pythagorean theorem because we're going to assume our antenna is straight up and down. At least we're hoping it is if we build correctly. And we're going to assume that the ground is flat, although that might not be true. Okay, so they would put it on concrete, though that would be flat. Okay, so we've got a 90 degree. Okay, so across from the 90, that would be my hypotenuse. So I know it's going to be equal to 50 squared. And so then I've got x squared plus 20 squared equal to 50 squared. Okay, the 50 is not allowed to be anywhere else. It has to be equal to 50 squared because that's my hypotenuse. So x squared plus 400 is equal to 2500. Okay, that's just squaring the 20 and the 50. Subtract that 400 over. Okay, x squared is equal to 2100. Take the square root of both sides. X is equal to. So the exact answer is 2100. Again, that technically could reduce as far as that radical goes, but that's an exact answer, and I'm okay with that. And then the approximate there, if you plug that in your calculator, you get like 45.83 feet. Okay, units are always important. Make sure you have those on there. So 45.83 feet, that's what we have for part A. Okay, I guess I could have done that up in part A, but this is my A. Okay, now B. Okay, local regulations require that a supporting wire be attached to at a height no less, okay, so that's my minimum, than 3/5 of the total height of the antenna. From part A, have local regulations been met? So, all we need to know, we know we attached it 45.83 feet up, okay, that's where this is at. We just need to know whether that meets the 3/5 requirement. So, 3/5 of 75. In mathematics, of means multiply. So 3/5 of 75. Okay, you can toss that in your calculator or just reduce. 5 goes into 75 15 times. 3 times 15 is 45. Okay, so I get 45 feet is my regulation. I did it 45.83. They said no less than 3/5. Okay, so if no less than 3/5. So 45 is my absolute minimum. It has to be higher than that, and we are. So the answer is yes, regulation is met, right? The height of, have the regulations been met? Yes, regulations have been met. And that is the end of the solving, and the next time we will pick up with complex and imaginary numbers. Good luck.